Okay. So when we looked at our lab data, I'm just going to get one specific equation that you guys had just to kind of talk through a little bit. So we had circumference is equal to some slope in units of centimeters divided by centimeters times diameter plus some y-intercept. And we basically decided that that y-intercept was significant. So even though they weren't exactly 0, we decided that it was either less than 5% of the maximum y value, or we reasoned that if you have 0 diameter, you should have a 0 circumference, and therefore the y-intercept is insignificant. Sarah, would you mind telling me what was your slope for your group?
I think it was 3.09, maybe. Okay,
3.09. I'm just going to round up to 3.1. Okay. So based on the measurements that they made on circumference and diameter, this was the equation that they got. But we just discussed that we can forget about the y-intercept, so that's not relevant in our equation. And we also decided what that number represents. So somebody remind us, what did we say the slope represents based on all of our data? So, pi, right? So let's just replace that number in unit with pi to get a general equation. So that can change to circumference is equal to pi times the diameter. Okay? So the equation above tells us is based on the specific measurements that they made, but after comparing all of our results and coming to consensus that all of our slopes were close to pi, we can just replace that with pi. And so this equation now we can use to predict the circumference or calculate the circumference of any circle, not just ones that you made. They can be much tinier circles than you use, or like much larger circles than you use. All right. So at this point, normally you guys would go, I'd give you guys time in class, or depending on how much time you had, just to kind of work through these conclusion questions. But instead, since this is our first one, like I said, we're going to kind of go through and write that up together. Okay. So when you write the conclusion for any of our lab reports, it's always going to be answering the same 8 questions. And you have it. Why don't you guys get out that lab checklist sheet that I gave you? It was like the 3rd page of that little packet, which tells you exactly what I'm looking for. Should be numbered 1 through 8, and it's that 3rd page. Just in general, I might use a little bit of shorthand up here, not write everything out word for word, but in your lab report, please use full sentences when you're kind of writing these things out. And please don't put it in just like one big paragraph that I have to like pull out everything. Like number it always 1 through 8. And just don't pre-number it, because you might need more space for the one section than the other. All right. So question number 1 is really simply trying to answer or come up with an answer for our purpose statement. Our purpose was, remember, to determine the relationship between the circumference and diameter of a circle. And that simply is answered by looking at the shape of our graph. So the shape of our graph, we decided, somebody said, was that it was a linear or proportional relationship. If one goes up, the other one goes up. Okay. So all you need to write out is the relationship between the circumference and diameter of any circular object is that it is a linear relationship or a proportional relationship. Pretty simple. Question number 2 and 3 and 4 and 5 all relate to the slope and the y-intercept. So question number 2 asks us, like, what did we decide as a class the slope represented? And like we talked about before, we said that the slope is equal to pi. So it could just be one sentence. We're going to decide that it's related to or equals something, and we'll just write that down. And then number 3 will always be, what is our evidence? Like, how do we know that the slope is equal to pi? So how did we come to that conclusion? Yeah, Andy?
Because the equation to get circumference and diameter is pi times diameter, and that's what the slope represents in the graph.
It's true. So you're actually reasoning from previous knowledge. You know that to get the circumference from the diameter, you multiply by pi. So let's say we didn't know that, right? And well, we said it's pi or about 3.1, 3.14. Let's say we'd never taken a math class or learned about the mathematics involved with circles. Like, I suppose we couldn't say that it's pi exactly, but how do we come to the fact that you multiply the diameter by about 3.1 to get the circumference? Yes. Yeah, we looked at a bunch of graphs, and what was the consensus, the agreement of our graphs and our data? Well, simply that what? Yeah, that all of our equations had about pi times the diameter. So the evidence is that, I don't want to say all, most of our slopes were approximately 3.1. And now we can appeal to previous knowledge that 3.1 is really, really close to 3.14, which is pi. Right? If we made super, super, super accurate measurements, guess what all of our slope would end up as? Pi, right? 3.14, and the more accurate measurements we made, the more sure we could have been of the successive decimal places of pi. And that's how we get pi. We just have, circular objects with the exact radius, and we make very, very precise measurements, and that's how we come up with the value of pi. And computers can do that much more accurately than we can. But that's where pi comes from. It's a ratio of the length of the circumference relative to the length of the diameter. Okay. Awesome. And again, all this stuff, remember, this is shorthand. You guys are writing out full sentences. Number 4 is really, we want to know about the y-intercept. Is it significant? Should we keep it, or is it insignificant? We can literally just erase it and forget about it. So somebody remind us what our conclusion was. Insignificant. You're right. So you would write out that the y-intercept is insignificant. Okay. If it was significant, you'd have to write out what it actually meant. Based on that sample set of data we talked about with the height and age of boys, you'd have to write out the y-intercept is significant and is the average birth height of a boy. Okay, so you have to tell us what it is only if it is significant. Okay. Well, number 5, just like number 3, is what evidence or reasoning do we have to suggest that the y-intercept is indeed insignificant? Somebody remind us of something that you use to dismiss it. Mia.
Logic.
Okay, tell me that logic.
That if there was zero diameter, there would be circumference, vice versa.
Yes, yes. And the way I'd like you guys to phrase it, as the diameter approaches 0, we would expect the circumference to also approach 0. Just an A in there. Okay. Number 6 and 7, both of these, you'll answer if there's any new terms that we discover or come up with or define within our lab. The only thing that came out of our discussion was the fact that it's like the slope is pi, and shouldn't be any shock. I mean, you've all heard of pi before, so that's not a new term. So for this lab report, you guys don't have to have a 6 or 7. Okay. But in future labs, we will develop new ideas, new definitions. 6 will be defining the new terms, and number 7 will be where in the lab like those terms come from. Whether the slope was the y-intercept or something else. Okay, and then the last one, concluding question you will always answer is, what error crept into our lab? Now, we just got done talking about that the slope should have been 3.14, and the y-intercept should have been 0, but nobody had those values exactly. And the question is, how come? How come nobody got those things like spot on? Yeah.
Just like human error.
Okay, I like where you're going with that, but we need to be more specific. So we said there's human error, we cannot measure things precisely. Okay? If you write down human error for number 8, you will not get any points. And if you write down measurement errors, you will not get any points because I want you to be more specific than that. So can somebody be more specific about what specific errors did we have that allowed error to creep into our data?
The measure on the meter stick be different from the measure on the board.
And are you talking about, did you use like a string without, did you use a measuring tape or did you use just like a string? Okay. Those, we're going to assume that whoever made those measured the centimeters out accurately. So that shouldn't have been our error. Actually, that could have been an error from a manufacturer, but we have no way to tell that. But that could be an error. Yeah. Anything else? That's a possibility, but we're going to assume that they did it right. Yeah.
The measuring tape couldn't have been perfectly around the diameter. The exact diameter.
Okay, so you use measuring tape to do the diameter. So yeah, so like it might not have been on the exact diameter. And why couldn't we find the exact diameter each time? What did we talk about in the beginning? What didn't we have?
We didn't know which was the center
Yeah.
of the circle.
Exactly. We didn't know exactly where the center of the circle was, so we weren't sure absolutely that we were measuring the precise diameter. So what you would write is imprecise diameter measurements because we didn't know where the exact center was. If that doesn't mean that they were totally wrong and incorrect, that just means they were a little imprecise. And every little imprecise measurement or thing will introduce error and cause us not to get the results that we should get if we can make perfect measurements. But that's impossible. Okay. What about circumference? There's got to be error in that. What was something that you guys observed which might suggest that some of your circumferences weren't spot on? Yeah.
In order to see the measurement on the tape, you gotta kind of move it below. Change your measurement.
I like that. Yeah, so it's right around, like the tapes are overlapping. In order to see like that measurement, you have to move it over, which means you're artificially, are you making a larger measurement or a smaller measurement by doing that? You're making a little bit larger measurement. So you're artificially inflating the size of your circumference, but like by a tiny, tiny little bit, which might be a reason if you did that consistently, why your slope was a little bit higher than 3.14 rather than lower than 3.14. Sometimes there's like random error, sometimes there's systematic error, which would cause you to have a higher value or a lower value than other things. Okay, so we kind of go through this like in detail because I want you guys to think. Don't just say, "Oh, we're not perfect. We'll never be perfect. That's why there's error," or it's measurement error. I just want you guys to like really think about the lab and think about what's causing it, which will also help us in the future minimize error because we know where it's coming from. Cool. Any questions about any of this stuff?